So today we're doing 2.7, solutions of functions. Can you double underline the fun? Actually, these aren't bad. These aren't bad at all. They are kind of fun. They're kind of like little puzzles, and I'm going to show you a cool way to do, especially when we get to the little table ones down there. We're going to do it visually, but then I'd like to show you how you can do it without even having to graph it necessarily. So, all right, here we go. This is the function that's given. This little upside down parabola thing is f. Okay, the line coming through here is g. All right. Label all, or list all the labeled points, that is a, b, c, d, e, whatever it is, for which f of x equals 0. Okay, where is the function value? Now, is f of x, is that x or is that y? That's y. I want to know where y equals 0 on the f function only. So here's my f function. Now, typically, where it equals 0 is either going to be b and e or it's going to be c, right? Those are the places when it hits the axis. Where is the y value 0? E and B, right? At the x-axis, that's how we found, in fact, that's how you find x-intercepts. You plug in 0 for y. You set the function equal to 0. So these are the x-intercepts. So we would say the answer to this is B and E. You good with that? These are the x-intercepts because when y is 0, that gives you the x-intercepts. Okay? List all the labeled solutions for y equals f of x. This, to me, at first was like, what? What are they asking there? Y equals f of x. You know what this is? Just on the function f of x. What are all the points that are on it? Okay, so what are all the ones that are on just f? A, B, C, D, and E, but not f and g, right? Okay, so we'll list all of those. A, B, C, D, E. So again, look at what that looked like. Y equals f of x. That's just the name of the function f of x, right? So just give them all. Okay? List all the labeled solutions for, okay, now this is different. This is where x equals 0 on f of x. So again, here's f of x. Where does x equals 0 on that upside down parabola? Right here. Yeah? Okay, so when x is 0, that gives you the y-intercept, the one that crosses the y-axis. That's where x is 0, right? Okay, now let's do it for g. Where are the points where g equals 0? Where g equals 0, that's the same as saying the y value on the g graph is 0. Where does that happen? That's f. Okay. List all the labeled points for y equals g of x. What's the answer to that? Where y equals f of x, g is one of them. There's more. F is one of them. There's more. A and D. This is another way of just saying give me all the points that are on G. Okay, so that's what that means. That's like this one up here, but this was on F. Okay, so A, G, F, and D. You good with that? Okay. List all the labeled points for when X is 0 on G. When X is 0. So would it be A, G, F, or D? Which one? G is when x is 0, right? Again, when x is 0, that's the y-intercept. Maybe we want to make note of that. This is the y-intercept, meaning where it crosses the y-axis. Okay? All right, now how about this one? List all the labeled points for when f equals g. What's that going to be? When does f equal d? Where they cross, right? Which is A and D. Okay. Now h here, f of 0, we've actually already answered this question. It's just now being presented in a little different format. Would you say the 0 is in place of the x or is in place of the y? What usually goes right there? F of x. Okay, so this is the same as asking on the f function, when is x 0? We did that right here. When x was 0, the f function, you know, this is the same, this is asking the same thing. 0 is in the place of x. That's the same as the y-intercept. So as you look at that graph, f of 0 is c, okay? So what's g of 0 going to be? G. We good? Any questions on that? You're going to have, I think, 3 problems like that, 2 or 3 problems like that on the homework. Okay, it should go pretty fast. Okay, now let's go to the table problems. The table below shows several points on two continuous functions. That's important. They don't jump. It doesn't make a big jump. It has no gaps. You're going to start at some point and you're going to just keep, your pencil's going to stay on the paper. You're not going to lift it off the whole time. Okay? That's important to be able to draw conclusions here. You guys, we're going to graph this first, but I'd really like for you to get to the point where you don't have to graph it. Okay, so the first thing I want us to do is go ahead and plot this. It's going to give you the table on the test, it's going to give you the table on the worksheet, and it's going to say if helpful. So I'll leave it up to you if you want to do that. I think visually it's nice to see why this is true, but I think we could do it just looking at the table. All right, so first of all, let's plot these points. Here's how it goes. When x is 0, f of x is negative 4. So plot the point 0, negative 4. Plot that point. And then going across here, plot the point 1, negative 1. That's how you read that. And then plot the point 2, 4. And then 3, 2. And since this function is continuous, somehow it goes from point to point. We don't know exactly. I mean, it might go up, and this might go up and back down and then up, whatever. We don't know exactly how it goes. It doesn't really matter. So I'm just going to have it go straight there, okay? But I don't necessarily know how it gets from that point to that point. I just know that when it hits the next value, integer value of x, it's going to be at that y location. Okay, so that's f. Now we're going to do g. If you have a different color, that might be helpful. Or maybe why don't you make g dotted if you don't have another color, okay? The way you read this table is when x is 0, g is negative 6. That's the point you're going to plot, 0, negative 6. Okay? 1, 2 is the next point. 2, 1 is the next point. 3, negative 3 is the next point. Again, now how this goes from point to point, we don't necessarily know, so I'm just going to make it go straight there. So from this point, it went up here, and then it went here, and then it went down there. That's G. So my pencil is G, my pen is F. Mark that. Or maybe you did dotted and solid. That's great. Okay, now, here's the directions. On the number line below, it's given, shade the intervals between the integers where the solutions to f of x equals g of x must exist. Must exist. You can guarantee that it has to happen. If it is not necessary that a solution exists, explain why. Okay, so first of all, up above, when we were finding where f of x equals g of x, we found where they intersected, right? Okay, this is pretty easy to see on the graph. Can you tell where they intersect? Well, right here. Again, how it got there we don't know, but the interval then is going to be between the x of 0 and x of 1. Somewhere between 0 and 1 it had to cross. So I'm going to put an open circle at 0, an open circle at 1, and I'm going to shade everything in between. Okay? And then as I keep going here, they intersected right here. Somewhere between 1 and 2, they crossed. Okay? So I'm just going to shade the area between 1 and 2. Did they cross between 2 and 3? Not necessarily. They may have, right? This graph may have gone up and crossed it and come back down. Could have done that. We don't know. Can we guarantee it? No. Okay, now, before we go on to the next one, I'd like for us to figure out a way, how could I, just by looking at the table, know that F and G had to cross? Look at the point, look at the y values. F was at negative 4, G was at negative 6 when they were at 0. Okay, when they went to 1, F went to negative 1 and G went to 2. How could I have told from that information that they had to cross? And maybe it might be helpful, like, why didn't why didn't they cross over here? Might be able to look at why why didn't they cross in that case? Okay, so we knew here they had to cross. Here f is at -1, g is at 2, and then f went to 4 and g went to 1, and they crossed. Somewhere they had to cross. But here, when it went from 4 to 2 and 1 to -3, they didn't cross. So how can I get that information just from the table without having to sketch it? Any ideas? Trying to figure out how to do this without having to graph it. Jason. Any ideas? You got a thought?
Going from 4 to 2 and going from 1 to -3, there's no numbers where they're the same. Like 4 to 2, 4, 3, and 2 don't interfere with 1, -1, -2, and -3.
Okay. There's no place where they're the same. So then the converse of that would be, okay, was there some place where these were the same? This one went from -4 to -1, and this one went from -6 to 2. Were there places where the numbers were the same?
Mm-hmm.
Yeah, there were. It's going to be even though a little bit more than that, because even if this had, say, started here at 2 and went straight down here, where they had a 2 that matched up, they still wouldn't have intersected. So that is part of it, but there's even a little bit more of a condition to that. Why, you guys? Why do they have to cross here? Why do they have to cross here, but not in that final interval? Okay, tell me about the functions here. Right here, you guys. This guy was f, this was g. Which one's greater? F is greater than g, right? F is above. Okay. How about here? What happened? G is greater than f. Okay, so here's g is greater than f. How about right here? What happened? F is greater than g. But here, f is still greater than g. They got to keep going back and forth. Or in other words, they got to, where f was above and g was below, they got to trade spots. They got to trade spots. Don't they, if they trade spots, they have to connect somewhere, right? If they're trading y values, somewhere they'd have to connect. So where f was above and g was below, then if f all of a sudden is below and g's above, they had to connect somewhere there. They had to cross. Okay, so here's what we could do. Here's a way I would approach this one. Which is above, f or g here? Which is above? Which is greater? F is greater. How about here? G. That means you need to shade that interval. Okay, now f is below. Which one's greater now? F. F is above. They traded spots. You need to shade that interval. Okay, here f is above. It's still above. You're not going to shade that interval. Okay, now that's only good for finding where they intersect. So on the next example, we're going to do that. We're going to use that strategy rather than sketching it. Okay, we're going to figure out where do they cross. Now, the next thing here, on the number line, shade the intervals where the solution to f of x equals 0, the place where f has to equal 0 must exist. On the graph here, my graph was this purple one. Did f have to equal 0 here? 0 is where it crosses the x-axis. Does it have to equal 0 here? No. How about in here? Yes. How about here? No. So we would have shaded from 1 to 2. Okay, now again, I'd like to be able to do this without having to sketch that graph. So look at the function values for f. This one went from -4 to -1, and we did not say it had to equal 0. This one went from -1 to 4, and we said it did. And this one went from 4 to 2, and we said it didn't have to. So what's the key there?
If the number in between is 0.
Okay.
From -1 to 4 is 0.
Between negative 1 and 4, zero's in there, right? Zero's between negative 1 and 4, so that's where we're going to shade. Okay, so for this next one, where does G have to equal negative 4? Same reasoning, but now look at G. Okay, Christina, you okay? All right, this G value goes from negative 6 to 2. Is negative 4 in between there?
Yes.
Yeah, so somewhere in there, and what you're going to shade are the x values. So between 0 and 1, it has to equal negative 4. Okay? How about from 2 to 1? Does it have to equal negative 4? Not necessarily. How about from 1 to negative 3? Does it have to equal negative 4? No, so we won't even shade that one. Okay, now we're going to employ that strategy on the back side, not sketch it. We're not going to sketch these. Okay, we ready? Here we go, reading A. Shoot, we got 5 minutes. We got to go a little faster here. This is what we're looking for. Same thing, you guys. Where does F have to equal G? Okay, what you're going to look for is where do they trade places. Okay, so here's how I do it. Which is above? F. Which is above? G. They traded spots. So you need to shade from 0 to 1. So come down here and shade from 0 to 1. Okay. Come back to 1. G is above. Which is above? G. Did they have to cross? No. Which is above? Still didn't have to cross. Which is above? Still didn't have to cross. That's it. That's the only place we could guarantee it. Pretty easy? Okay, let's do F and H. Okay, now make sure you're looking at the right ones. Here's F, here's H. Which is above? F. Which is above? Didn't cross. Which is above? Ooh, they traded H. They traded spots here, so I'm going to shade from 2 to 3. They traded spots. Okay, so come down and shade from 2 to 3. Okay, and then go back to 3. We said H was above. Who's above now? F. Did they have to cross? Yep. So shade also from 3 to 4. Okay? Let's do it now with G and H. Okay? Where the two things have to equal, they have to trade spots. Okay? So who's above? G. Who's above now? G. Who's above now? Who's above now? Who's above now? What does that mean? They never necessarily had to. And so this says, where must it exist? No solution. So we're supposed to write no solution, and then you're supposed to explain why. Here's what I would say for this. G was greater than H, right? Wasn't that what we found? G was greater than H for all given values. It's possible that in between they traded, but based on what we could see, they never traded spots. But again, it might have gone, funky and swooped up or something. Okay, so again, that's when you're looking for two functions to be equal. Who's above? Who's above? Who's above? Okay, let's go to now D. When does G have to equal 5? When does it have to equal 5? So just looking at G, does it have to equal 5 between 0 and 2? No. Between 2 and 6? Yes. Okay, so what you're shading, though, is from 1 to 2, because that's where the function equals 2 and then 6. How about from 6 to 7? Does it have to equal 5? Not necessarily. Between 7 and 8? Not necessarily, so we're only shading where it has to. Okay? Last one, where does H have to equal 0? Okay, so look at H. What would you say? Between 1 and 2 and 3 and 4. So you'd shade 1 to 2 and you'd shade 3 to 4. Okay, so that assignment, if you got the hang of that,